Hello everyone, I hope you're weathering this weird situation well. I just wanted to give you a quick video to show you some examples of the practice I want you to try today. This should be review for you guys. And what I decided is we're just going to focus on a little unit of polynomials, and we'll do a little bit each day and sort of stop the statistics because it gets a little more complicated than I think we can manage via online. So here I'm going to keep this video really short. If you have questions about anything that I say in the video, send me an email, send me a Schoology message, or I put in a discussion board on your Schoology where you can ask any math questions that you have. All right. So we're going to talk about operations on polynomials, which really operations meaning add, subtract, multiply, and divide. Again, you know how to do this, so I'm just going to give you a little refresher, and then I want you to try some of the practice today. And the practice, just so you're aware, it's just like we would do in class, so treat it like an assignment. You get 3 points for doing it. And you have 3 attempts to do the Schoology practice, so you want to get as good a score as you possibly can, but your points are for actually completing it, not for what you get right and what you get wrong. So anyway, let's talk about adding and subtracting. So my first example, I have 2x squared plus 3x minus 1 plus 4x cubed minus 2x squared plus x plus 7. The first thing that we want to do is look for like terms. And when we're adding, remember that our exponents stay the same. So I'm going to start here with 2x squared. I see another x squared on the right, and it's a negative 2x squared. Well, positive 2x squared and negative 2x squared, that gives me 0x squared, or those would just cancel out. I see on the right-hand side, though, I actually have this 4x cubed. That's the highest power. That's the one that I want to write down first. Since there are no other x cubes to combine it with, I'm just going to bring that down as the beginning of my answer. So I've used that. The x squareds were canceled out. Next I have just an x, so I have a positive 3x and a positive x, and remember there's like an imaginary 1 there. So that's really a positive 4x. And then lastly I have a minus 1 and a plus 7. Which would give me a positive 6. So my answer is written in standard form when it's in descending order, which just means that the powers go from highest to lowest. All right. Just to give you a few little things to jot down. So this would be my final answer. Again, my exponents don't change. I'm just adding or subtracting the numbers in front. The second example here, we are subtracting. So when I think about subtracting, I'm going to think about almost distributing this minus sign all the way across. So I have 3x to the 4th plus 5x minus 8. And then I have a minus 7x to the 4th. Minus negative 3x makes that a plus 3x, and minus positive 1 is minus 1. Now instead of having to think about subtracting each time, I can just go through and add my like terms. So again, I'm going to look for the highest power first. I have 3x to the 4th and negative 7x to the 4th. 3 minus 7 is negative 4, and my power doesn't change, so x to the 4th. Next highest power we have is just an x. Positive 5x and a positive 3x is a positive 8x. And then negative 8 and negative 1 makes negative 9. So again, I've written them in standard form because it's descending order. And I combined all the like terms that I could. All right. Now let's look into some multiplication. So when I multiply, if you remember, my exponents are going to change. So if you recall, when we multiply powers, or multiply variables, excuse me, we're going to add our powers. So 3x squared, when I distribute that, 3x squared times 2x is 6x to the third. And then 3x squared times 6 is negative 18x squared. So I added the power here. X squared times x is x to the third. And then with the 6, there was no other power, so this x squared just gets tacked onto the end. And that is my final answer because there's no more like terms I could combine. Okay. And then lastly, we want to think about division. So I know it looks like a scary fraction, but it's really just division. And so let's take it one step at a time. We're going to do each piece. So the first piece would be 10x squared divided by 2. And then the next piece would be 6x divided by 2. And the last piece would be negative 3 divided by 2. That looks a little messy here. So what I'm doing is taking the first term, dividing it by the denominator, taking the second term and dividing it by the denominator, and then doing that with the third term as well. So now we can simplify 10x squared divided by 2. Well, there's no x to deal with, so I'm just dividing the numbers, so I get 5x squared. Then 6x divided by 2. 6 divided by 2 is 3, and the x remains. And 3 divided by 2 is just 3 over 2, or 1.5. Again, highest power to lowest power, and there's nothing else I could combine there. All right. For the last example, we're doing the same exact thing, but now we have a variable in the denominator to think about. So first, 9x to the 5th divided by 3x. So 9x to the 5th divided by 3x. Well, that's going to give me 9 divided by 3, which is 3. And remember, when we divide variables, we subtract powers. So if I have x to the 5th over x to the 1st, that is x to the 4th. All right. Next, we're going to do 27x squared over 3x. 27 divided by 3 is 9, positive 9. X squared divided by x to the 1st is just x. You can write the power of 1, but you don't really have to. And then lastly, negative 6x divided by 3x. So minus 6x divided by 3x. 6 divided by 3 is going to give me, negative 6 divided by 3 is going to give me negative 2. And x divided by x, those would cancel out. So this is my final answer. Each one of those powers in the numerator are now one power less because we divided by an x to the 1st. Right? So go ahead and give that Schoology practice a try. Email me with questions, post them in the discussion board, and please continue to communicate with me. I hope you all are going to have a great St. Patrick's Day.